Hello everyone, welcome back to another kinetic tutoring video. Today we're taking a look at the AP test from 2024. Here we have question 2 from set 1, so let's get straight into it. A student drops a cylinder of mass m from rest. The air exerts a drag force of magnitude Fdrag on the cylinder as shown in figure 1. The student models the magnitude of drag force as Fdrag is equal to bv squared, where v is the speed of the cylinder and b is a positive constant with approximate units. Part A is asking us to derive but do not solve a differential equation that could be used to determine the speed v of the cylinder as a function of time t. Express your answer in terms of given quantities and physical constants as appropriate. Alright guys, so this part is pretty straightforward. All we have to do is firstly write out our force equation, MA. We know we have the force of gravity going downwards, mg, and then this drag force going upwards. Here we go, and then we just have to slightly tweak this. We're gonna try to get acceleration on its own. So A is equal to g minus bv squared over m. And our final step is just to simply rewrite A as dv dt equals g minus bv squared. And here you have it. Here is your differential equation. That's all you gotta do. So let's move on to part B. The student correctly sketches the speed v of the cylinder as a function of time t as shown below. Draw a vertical line on the sketch in figure 2 to indicate the earliest time at which F drag on the cylinder is equal to the magnitude of the weight of the cylinder. Label this time as t1. So guys, it's saying that at a certain point our bv squared is equal to our mg. And when our mg is equal to our bv squared, this means that our acceleration is going to reach 0. And when our acceleration reaches 0, our velocity is no longer changing, and we can see that this happens somewhere around here. So we can draw our line here. Sorry, this isn't a perfect line. And then we can say that this approximately happens here. And so this here is going to be our t1, and the explanation is just that there is no acceleration when the velocity stops changing, and therefore that's when we know that the drag force is equal to the force of gravity acting on the object. And in other words, this means that the object has reached its terminal velocity. Let's move on to part C. Rather than dropping the cylinder from rest, the student throws the cylinder upwards with a non-zero initial speed. The cylinder is in the same orientation as when the cylinder was previously dropped. The student allows the cylinder to fall towards the ground. Indicate whether the magnitude of the cylinder's maximum downward speed be greater than, equal to, or equal to speed Vmax in figure 2. It's the Vmax here. So, in order to solve this, we must understand how a maximum speed is acquired, how a terminal speed is found. So let's take a look here. This is our terminal speed. Our velocity here is our terminal speed, and we know this because the object is no longer accelerating. So let's find this v. So if we move the b over to the other side, we'll get this. And then our terminal velocity is just the square root of mg over b. And as we can see, this has nothing to do with initial velocity, meaning that our initial velocity will not play a role in the terminal velocity. These two are completely separate and they do not have an effect on one another. So let's move on to the next parts. Alright. Part D gives us a graph of v squared over m, and it asks us to draw a best fit line for the data. This is a rough best fit line. If you're actually taking an AP test, you would want to use a ruler. Use the best fit line to calculate an experimental value. Alright guys, so we can see that we'll just use like a point here because it's on the line. We can see that it has risen 8 and it has ran 0.5, meaning that the slope is 16. So v squared over m is 16. Let's jot that down. And now let's go back to our equation. We had mg is equal to bv squared. And if we want to find v squared over m, so we'll divide both sides by b and m. We will get g over b is equal to v squared over m, meaning that g, which is approximately 10 over b, will give you 16. 10 over b is equal to 16. 10 is equal to 16b. And that means that our b is equal to 10/16 or 5/8. So there you have it. That's how you would find your b. b is equal to 5/8. And now let's go to part E, the final part. A student claims that the magnitude of the maximum speed of a cylinder dropped from rest depends on the length of the cylinder. The student designs an experiment to collect data that can be used to provide evidence to support the claim. The student drops cylinders with the orientation shown in figure 3. The student has access to, but does not have to use, all of the following equipment: cylinder set 1, cylinders of the same known length and different known masses; cylinder set 2, cylinders of the same known mass with different known lengths. Alright, and it's asking us to indicate the two quantities when graphed. That one graph could determine whether the length of the cylinder affects its maximum speed. So we're going to have our maximum speed on the vertical axis because that is the dependent variable. That is a variable that we're tracking that changes dependent on what we are changing. And since we have a v squared in our equation, instead of just having regular v, we're going to put v squared here just to keep it simpler. On the horizontal axis, it makes sense to put the independent variable, which is the variable that we're changing, which should be the length. So we'll put the length here, and we'll see that if the length does play a role, as the length increases, the vertical axis is going to either go up or down based on how this affects it. And part 2 is just asking us to briefly describe how the graph could be determined. So let's take a look at our equation at terminal velocity. We have mg is equal to bv squared. And what I would do is say that I chose cylinder set 2, where the masses do not change but the lengths do change, because we know that the lengths will play a part in the b portion of this equation, because as the length increases there will be more drag force, because obviously when we have a larger object it is more affected by air resistance. And the mass is going to remain constant. The gravitational constant is obviously going to remain constant. So we will have a c, we'll just replace mg with c, is equal to bv squared. So as we can see, as the length increases, or we can say as the length goes to, for example, infinity, we can see that our b will also go to infinity. And we know that our v squared is equal to c over b. So as b goes to infinity, our v squared is going to approach 0, which makes sense because the bigger the object is, the more air resistance it's going to face. The more air resistance the object faces, the slower its terminal velocity is going to be. So that's how I would solve this problem. There are many other ways to go about it, but this is the one that makes the most sense to me. And that's what I put on my College Board exam. So that's all I have for you guys today. Hopefully you learned something. Hopefully this video was helpful. If there are any further questions, make sure to leave them down in the comments below, and I will see all of you next time.